All right. Um, Welcome back to my channel. In this video, we are going to be talking about, this is continuation of the previous video on partial differential equation. Remember, in the previous video, I talked about, we defined partial differential equation. We gave an example to partial differential equation. We talked about how to find the order, the degree of a partial differential equation. We talked about the dependent variable and the independent variable of a partial differential equation. Then we'll now talk about formation of a partial differential equation. So if you have not watched the video, you can look out for the video. I think the link will be on the description. You can watch the video first before this particular one. So in this video now, we want to talk about the solution to partial differential equation. And then remember that we have, apart from by direct integration, we have three analytic methods of solving partial differential equation. I think let me start from by direct integration. Then we'll now move to the main thing, which is the analytical method of solving partial differential equation. Okay, so let's first of all talk about by direct integration. Direct integration. Okay, so we're going to be solving an examples from that. Then we'll now move to the main thing we have. Okay, this one is just as simple as ABC. So let's just talk about that. So the first example here, say we should solve partial cube z over partial x squared partial y is equal to cos 2x plus 3y. Okay, so by direct integration, all we need to do is just keep on integrating. And if you look at it, see that we are going to integrate with respect to x twice, because they differentiate with respect to x twice, then differentiate with respect to y. So if we integrate with respect to x twice, we will now integrate with respect to y. We are done. This is very, very simple. So solution. So I'm going to have the integral of partial cube z over partial x squared partial y. We're going to integrate with respect to what? With respect to x. We're going to integrate with respect to x is equal to what? The integral of cos 2x plus 3y, then with respect to x again. So now, in this case, if you integrate this, you see that one of these will take care of this. So I'm going to have partial squared z over partial x. One of these is remaining. Partial y will now be equal to the integration of this. Remember, this is function of a function. So we are going to differentiate inside here. Use it to divide the integration of everything. And the differentiation of 2x is 2. The differentiation of 3y with respect to x is 0. So that one, we're having 2 here. So we're going to put the 2 at the denominator. So the integration of cos something is sine that thing. So I'm going to have sine that 2x plus 3y. Okay, so I'm going to have plus, instead of arbitrary constant, we're going to have arbitrary function. And this arbitrary function, because this is partial derivative, in fact, I think this is going to be like this. So the arbitrary function is going to be with respect to y. So anytime you integrate with respect to x, the function you are putting will be with respect to y. So I'm going to have with respect to y arbitrary function. Why? Because I integrated with respect to x. So now we're going to integrate again with respect to x. So if you integrate with respect to x, to eliminate this one, I'm going to have the integral partial square z over partial x partial y, then partial x will now be equal to what? 1 over 2. Let me bring out the 1 over 2 outside. 1 over 2, the integral again of sine 2x plus 3y, okay? Then the x, then plus the integral again of f of y, then the x, okay? So now, having this, I'm going to have that this is equal to, this will not take care of it, to have that this is partial z, partial y is now remaining, will not be equal to, differentiate this inside again, you have to use it and divide. So I'm going to have 1 over 4 the integral of sine something is minus cos that is. So let me put minus here. Minus, I'm going to have cos, then 2x plus what? 3y. Now, the integration with respect to x is to bring in x here. So I'm going to have plus x f of y, then plus another function of y again. Why? Because I integrated with respect to x. So now, lastly, I'm going to integrate with respect to y. So if I integrate with respect to y, I'm going to have the integral of partial z, partial y with respect to y will now be equal to the integral. Okay, let me put the constant outside. Minus 1 over 4 outside. The integral of cos 2x plus 3y. Okay, then the y with respect to y. Then plus, I'm going to have the integral of x f of y dy, then plus the integral of g of y dy. Okay, so now, so this is going to be differentiating with respect to y. We're going to differentiate inside here with respect to y. Use it and divide the integral of everything with respect to y. So differentiating 3y is 3. Differentiation of 2x is gone, 0. So that 3 will come and divide this to have minus 1 over 12. So the integration of cos something is sine that thing. So sine 2x plus 3y. Okay? So this one is done. So now this one is now, I have plus, if I keep my x as a constant, differentiation of integration of a function of y will still give you another function of y. So let me put it as capital letter of y. So we know that it's going to be a function of y. Okay, so plus, so integrating something again with respect to y will give you another function of y. So let me take it as capital letter of y. So then plus, let me say fgh, h of x. Why did I put this arbitrary function? Because I integrated with respect to y. I'm going to put an arbitrary function with respect to x. And so if this take care of this and differentiation take care of integration, I'm having z. So this is now my solution. That is by direct integration. Very, very simple. So we'll take another question. Take another question. Question number 2. So question number 2 said we should solve partial square z over partial x partial y of x squared y. Okay, by direct integration is very simple. So what do? The same method again. We're going to integrate with respect to x and integrate with respect to y. So to integrate with respect to x, I have partial squared z over partial x partial y with respect to y, or with respect to x first, is equal to what? The integral of x squared y with respect to x. So here, this will take care of this. I'm having partial z, partial y remaining here is equal to, integrating with respect to x, add 1 to the power, divide by the new power. So I have 1 over 3 x cubed y, then plus what? A function of what? Y. A function of y. Why? Because I integrated with respect to x. So now let us integrate with respect to y. We're going to have the integral of partial z, partial y dy will now be equal to what? The integral. Let me leave 1 over 3, the constant outside. 1 over 3, the integral of s cubed y dy, then plus the integral of f of y dy. Okay? So now, everything here, z is remaining, is equal to, add 1 to the power, divide by the new power. So 1 plus 1 is 2. So I'm dividing with 2 to give you 1 over 6. So 1 over 6 x cubed y squared. Okay? Plus, integrating a function with respect to y is going to give you another function of y again. So another function, capital letter now, another function of y, then plus now a function of x. So that is that, as simple as that. That is the solution to that particular problem. So we move to the next question. Okay, in this one, they gave us they gave us condition. The condition they gave us here is that z of 1 comma y is cos y. cos y, and z of x comma 0 is x squared. Okay, so now, so since they gave us that condition, when we got this one, so we can substitute. Let us substitute. This one said that when y is 0, that z is x squared. When y is 0, z is x squared. So to substitute this second condition, and then for the first condition, when x is 1, that z is this. So to get these two functions, I'm going to have when y is 0. So if I put y is 0, x is x squared. So I'm going to have x squared. So instead of putting z now, z is equal to, this thing means that z is a function of x and y is equal to anything. So which means my z is equal to x squared when y is 0. So I have x squared is equal to, and our x remain the way it is, our x remain the way it is. So I'm going to have, so if I put 0 here, 0 times everything here is gone. Okay, so I'm having f of 0. So I'm having f of 0, then plus g of x. So to make g of x subject, g of x will now be equal to what? X squared minus f of 0. Okay, so that is that. So if I put it back, immediately you get it, come and put it back. If I put it back, I'm going to have that z is equal to 1 over 6 x raised to power 3y squared plus our capital letter f of y, then plus, instead of writing g of x, I will now write plus what? X squared minus f minus capital letter f of 0. Okay, so now the next condition here is that when x is 1, our y remain the way it is, then z will now be cos y. So if you put it here in this last answer, I'll have that what? Cos y will now be 1 over 6, x is 1. So 1 raised to power this is the same thing. So I have y squared here. Okay, so plus f of y, capital letter f of y, capital letter f of y, then plus my x squared, this is 1 minus f of 0. Okay, so capital letter f of 0. So to make this subject, I'm going to have that f of y will now be equal to what? In fact, multiply everybody by, okay, will now be cos y minus this one going here to have 1 over 6y squared. This one coming here, I'm going to have minus 1. This one going back there, I'm going to have plus capital letter f of 0. So put it back everywhere again to have that your z will now be 1 over 6 s cubed y squared plus, instead of writing this, you now write cos y minus 1 over 6 y squared minus 1 plus f of 0. So then plus x squared minus f of 0. So f of 0, take care of f of 0. I'm left with what? Z is equal to 1 over 6 x raised to power 3 y squared plus cos y minus 1 over 6 y squared minus 1 plus x squared. So, and that is the final answer for that particular question. So we move to the next question, question number 3. See, this is very, very simple, by direct integration. Okay. So question number 3. Question number 3 said question number 3 said we should solve partial squared z over partial y squared is equal to z. Okay, and then they told us that that y is equal to 0 when z is equal to exponential x, and then partial z partial y is equal to exponential minus x. Okay, so now what do we do in this case now? Since we have that that z is just a function of, okay, Now, if z is just a function of x, I'm going to solve this in another way. If z is just a function of x, just one function. If it's a function of x, remember that that we're going to solve this like this. Remember, let me solve it using the normal ordinary differential equation. If this is ordinary differential equation, I'm going to have that what? Let me change this to y and z, y and x. So this is the squared y over the x squared is equal to y. So this is how it looks like. Or let me use z and y as the same thing so that you understand. So this will now be, if it's ordinary differential equation, it's going to be this the squared z over the y squared, okay, is equal to what? Z. So this one coming here, I'm going to have the square z over the y squared minus z is equal to 0. So this is second order homogeneous differential equation. So we're going to get the auxiliary equation. So the auxiliary equation here is going to give me m squared minus 1 is equal to 0, right? So to have that, this one moving here, I'm going to have that my m is equal to what am I having? Is that okay? My m is equal to 1. Then I'm going to have that my m will now be plus or minus the square root of 1, right? Yes. No. Sorry. So this is going to be m squared minus 1 is equal to 0, yeah. And m will now be plus or minus the square root of 1. So m will now be plus or minus 1, right? Yeah, plus or minus 1. So therefore, in this case, so therefore my z will now be equal to what? A cos y, okay, a cos y plus b sin y, okay. Yeah, so that is how it will look like, if I'm not mistaken. Yes, that is how it will look like, if I'm not mistaken. So but in this case now, you see that z is not just a function of y, but a function of x. That is why they say that z is equal to exponential x. So putting x here, you know that even without that, you should know that partial differential equation is always a differential equation that contains two independent variables. So the independent variable must be 2. So in this case now, I'm going to have that this will now be z will now be equal to what? A function of x cos y, okay, plus another function of x sin y, okay. So that is how the solution will look like. That's how the solution will look like. So if we now substitute, what do we have? So just substitute what we have. We have that when z is exponential, this is that y is 0. So I'm going to have that this is what am I talking about? So this is exponential x is equal to what? F of x cos 0 plus g of x sin 0. Okay? So you should know that that sin 0 is 0. So cos 0 is 1. So I'm going to have that this is 1. So therefore, our f of x is equal to exponential x. So they told us that the x, the z, the y is equal to this when y is 0. So we have to differentiate this partially with respect to y. So I'm going to have partial z, partial y will now be equal to differentiate cos. You're going to have sin, right? So I'm going to have that this one will give you so this one is going to give you f of x sin y plus g of x cos y, okay. So having this now, we now substitute. So if we substitute, we are going to have this is equal to exponential minus x. So exponential minus x is equal to what? F of x sin 0 plus g of x cos 0. So again, I'm going to have that g of x will now be equal to exponential minus f, because this is gone. This is 0 gone. So if we now put it back in my equation, I will now have that my answer becomes z is equal to what? My f of x is exponential x. So exponential x cos y. This one is exponential minus x. So plus exponential minus x sin y. So that is the solution to that particular question. Okay. So we'll solve the next example. Okay. Example 4. So example 4 said we should solve by direct integration partial cube z over partial x squared partial y plus 18xy squared plus sine 2x minus y is equal to 0. Okay, so we should solve this. So what do we do here? We integrate. So with respect to x, and with respect to y, with respect to x again, or with respect to x 2 times, and then with respect to y. So to integrate with respect to x, the same method. So we integrate here. I'm going to have that is now partial squared z over partial x partial y, then plus integrate with respect to x, add 1 to the power, divide by the new power. So I'm going to have 18 over 2, which will give you 9. So this is 9x squared y squared, okay, plus differentiate here, use it and divide the integral of sine something. Integral of sine something is minus cos that thing. So minus cos the same 2x minus y, okay, is equal to, then you now put your function of y, because I integrated with respect to x, so I'll put a function of y. Okay, so go again with respect to x again. So I'm going to have partial z partial y now plus add 1 to the power, divide by the new power. So it's going to be 9 over 3. And 9 over 3 is the same thing as 3. So 3x raised to the power 3 y squared. Okay, so minus, we go again, differentiate here, you have 2. Use it and divide the integral of everything. So integral of this will give you sine the same 2x minus y. Okay, is equal to integrate this one with respect to x. X will now come in x f of what? Y. Then plus another function of what? Y. Why? Because I integrated with respect to x. So now let us integrate with respect to y. Integrate with respect to y. So this is gone. I'm having z remaining here. So add 1 to the power, divide by the new power. So it's supposed to give us 3 over 3 s cube y cube. Okay, so 3 over 3 is gone. So I'm left with s cube y cube minus, differentiate here. It will give you minus 1. So bring it here to make it plus. But the integral of sine is minus cos. So minus is remaining here. Minus 1 over 4 cos 2x minus y then is equal to, we are integrating with respect to y. So integrating with respect to y, I'm going to have, it will now be the integral. It will now be the integral. Do I put the integration, or integration of a function of y will give you a function of y? So let me leave x as a constant. I will now have capital letter of y, okay, then plus capital letter of y again, like that. So that is that for that particular one. We are done. As simple as that. Or you just put the integration if you like. You can just say, some people will say x the integral of f of y dy, then plus, okay, then I forgot plus a function of x, so h a function of x. So some will say the integral like this, then plus this. So the same thing, but I know that if you integrate a function of y, you will still get another function of y. If you integrate a function of y, you will still get another function of y. So that is that for this one. So we're going to solve one more question, then we move to the main thing we have. That is so other solution to partial differential equation. So these ones are still very, very easy. So we get one more question number 5, I guess, and they say we should solve by direct integration partial cube z over partial x squared partial y, okay, minus cos 2x plus 3y is equal to 0. So this one is pretty very easy. So this one is very, very easy. So what do? Integrate with respect to x to have partial squared z over partial x partial y minus differentiate here to have 2. Use and divide everything. So I have 1 over 2. Integration, of course, will give you sine 2x plus 3y, okay, is equal to a function of y. So a function of y, because I integrated with respect to x. So another one, integrate again with respect to x to have partial z over partial y remaining minus, this is 2, bring it down to have 1 over 4. But integration of sine is minus cos. So here becomes plus. So it's going to be plus cos 2x plus 3y, okay, is equal to, integrating with respect to x, I have x will come in as a function of y, then plus another function of y, okay. So finally, integrate with respect to y to have z here plus 3, bringing 3 outside here to have 1 over 12. 1 over 12 cos 2x plus 3y, okay, is equal to, with respect to y, I'm going to x, capital letter y like this, plus capital letter y again, then plus a function of x. So this one is pretty very, very easy. Okay, so like I said, some people will just put the sign of integration. So but you know that the integration of a function of y will give you another function of y. Okay, so let's solve the last question, then we move. Let's solve one more question, which is going to be the last one. So they say we should solve partial squared z over partial x partial y is equal to x squared y. Okay, I think I've solved something like this before. Okay, yes, I've solved something like this before. So you can try it and tell me the answer in the comment section. I think that is all for this particular video. So the next thing we're going to now look at is another method of solving partial differential equation. Okay, and I think let's do that in our next video, because I think that will be very long. Or let's just continue. So another method of solving partial differential equation is okay. Let's continue. So another method is we have three analytic method of solving differential equation. Let me close my. So you should know that we have three analytic method of solution. So analytic method of solving differential equation. And the first one is what we call the Euler's method. The Euler's method. Okay? Euler's method. Or let me just solve this in the next video. Sorry. Okay, or let me just list all of them. Then we will now start with the first one. So the second one is the Laplace transform method. Laplace transform method. Then the third one is integral transform method. Integral transform method. So we are going to start with this Euler's transform method in our next video. So thank you very much for watching this particular one. So don't forget to like, share, subscribe, and then drop your comments. Okay, it's very important. Bye bye.